Yes, good afternoon, everyone.
Good afternoon, sir.
Good afternoon, sir.
Good afternoon, sir.
Who is the CR? At least CR could have reminded me about our class. Hello, Uttam. No. Yes. At least, actually, I was slightly busy in the departmental institute work. Suddenly I remembered. What is the previous class? That madam has started chemical analysis. Hello?
Yes, sir.
Okay. What is chemical analysis? What is chemical analysis?
Detection and determination of constituents in a chemical substance.
Okay, detection and determination of chemical constituents which are present in the sample is called as chemical analysis. Yes, in the chemical analysis, what are the different types of chemical analysis?
Qualitative and quantitative. Qualitative
what is the difference between quantitative and qualitative?
In the qualitative analysis, we test about the colors, and in quantitative we determine the amount of the chemical substance.
Okay, so yeah, then quantitative analysis, how much amount of that chemical substance is there in the sample, that is called as quantitative analysis. So here what you have to remember, at the time of Viva Voce examination, we used to ask some Viva questions from the introduction portion. Introduction portion means define chemical analysis, what is qualitative analysis, what is quantitative analysis, then what is indicator, what are the different types of indicators, what are the acid-base indicators, what is complexometric titration, what is redox titration, what is permanganometric titration, what is the chemistry involved in the dichromatic titration, which indicator is used in the dichromatic titration, what is standard solution, what is primary standard solution, what is secondary standard solution, what is equivalent point, what is the difference between equivalent point and end point. Like this, some of the general questions would be asked at the time of Viva Voce examination. So the introduction portion you are required to read thoroughly. What is concentration? What is least count? Okay, these type of general questions. Getting my point?
Yes,
sir.
Yeah. So now today's our experiment is redox titration. Redox titration means Okay, that quantitative analysis again subdivided into 4 groups. The first one is acid-base titrations. Second one is redox titrations. So that redox titrations we are discussing. That means the redox titration comes under volumetric titration. Volumetric titration means simply we are measuring some amount of volume. Then from that we are determining the normality. So hence, okay, that is called as volumetric titration. So in the volumetric titration, another example is redox titration. So today's our experiment is redox titration. Okay. Yeah. So redox titration for the what is the definition of redox titration? Yes. Please reply.
When the reaction is redox involved in titration, then it is called redox.
Okay. Redox involved means what does it mean? Okay. In any chemical reaction, if oxidation and as well as reduction reactions takes place simultaneously, such type of reactions are called as redox titrations. So here in our practical, one of that experiments are there. So those reactions are permanganometric titrations and dichromatic titrations. So permanganometric titration is also one of the best example for redox titration and as well as dichromatic titration. So today's our experiment, we are going to discuss about permanganometric titrations. Okay, clear? Hello?
Yes, sir.
So in the permanganometric titration, what is happening? Same. Oxidation and reduction reactions are taking place simultaneously. Hence, it is also one of the best example for redox titration. That's fine. Today's our aim, today's our object is, what is our object? Strength of ferrous ammonium sulfate solution is N by 100. FAS, ferrous ammonium sulfate solution is N by 100. To find out the strength of given unknown ferrous sulfate solution in acidic medium by titrating against potassium permanganate solution as an intermediate. See, always you remember one thing. What is that? Always in the volumetric titrations, 2 solutions would be there. Out of that, one solution is the standard solution, another solution is the unknown sample. So with the help of standard solution, we are going to determine the unknown sample concentration. This is our fundamental. So similarly, here in our experiment also, 2 solutions are there. What are those? See, one solution is the standard solution. What is the definition of standard solution? Whose concentration is known. So here, the strength of ferrous ammonium sulfate solution is N by 100. That means ferrous ammonium sulfate solution normality was given. That is N by 100. That means 0.01 N. That means this is the standard solution. Now, with the help of this standard solution, we have to determine the strength of unknown ferrous sulfate solution. This is our aim. This is our object. Today's our aim is to determine the strength of ferrous sulfate solution. The ferrous sulfate is the hydrated ferrous sulfate solution. That means FeSO4 got 7H2O. That is the hydrated ferrous sulfate solution in acidic medium. Okay, that's fine. Now, okay, how we are determining, okay, against, okay, with the help of potassium permanganate solution as an intermediate. That means here we are using potassium permanganate as an oxidizing agent and it is as an intermediate solution. How that is intermediate? Yes, we will discuss. Okay, see, first of all, today's our aim. What is our aim? Yes, please speak out. What is our aim? Today's our experiment?
The strength of ferrous sulfate hydrated in acidic medium.
We have to determine the strength of ferrous sulfate solution because this is the unknown sample. One solution was standard, another was unknown. So we have to determine that. Okay, that I will discuss. See here, what is our titration? What is our titration? Permanganometry. Permanganometry means permangano. That means with the help of permanganate ions. Metry means measurement. So that means with the help of permanganate ions, we are determining the strength of unknown sample concentration. Hence it is called as permanganometry. Metry means measurements. Permangano means with the help of permanganate ions. That means MnO4 minus. That means that is the permanganate ions. Okay, that's fine. Now, okay, here what is happening? As it is, what we studied, this is the redox titration. So how it is called as redox titration? Yes, that what is the theory or what is the chemistry involved in this titration? That we are going to discuss. See, here N by 100 ferrous ammonium sulfate solution was given. Then two unknown solutions are there. First is ferrous sulfate solution is also unknown. Potassium permanganate solution is also unknown. So initial titration is the titration against the titration of ferrous ammonium sulfate solution against potassium permanganate. So by titrating with this, ferrous ammonium sulfate is acting as a reducing agent, potassium permanganate is acting as an oxidizing agent. So this potassium permanganate will oxidize the ferrous ammonium sulfate. When all the ferrous ions are converted into ferric, then that extra drop of potassium permanganate that gives the purple red color or otherwise reddish color. Okay, once again, that means, see here observation table kya hai na? First observation table is titration between potassium permanganate and ferrous ammonium sulfate solution. Ferrous ammonium sulfate solution strength was given, that is 0.01 N. Then potassium permanganate strength was not given. So with the help of ferrous ammonium sulfate, calculating the potassium permanganate normality. How? Simply you do the titration, pipette out 20 ml of ferrous ammonium sulfate solution, then titrate against potassium permanganate solution. When the solution turns to colorless to reddish color, then stop the titration. Then note on the end point. See here, okay, this titration is in the acidic medium. So we are pipetting 20 ml of standard ferrous ammonium sulfate solution. Then we are adding 10 ml of dilute H2SO4 solution. Then titrate against potassium permanganate. Continue the addition of potassium permanganate solution drop by drop till the color of solution just changes to permanent pink or otherwise reddish pink. Then note down the volume of potassium permanganate, that is the volume of potassium permanganate consumed. Then repeat the titration to get the concordant reading. See, what is the concordant reading? That means the next immediate reading should be same. The consecutive reading should be same. So for example, in the first titration, so let us assume that you got 10.0. That means volume of potassium permanganate consumed 10.0. Then, okay, after completion of first slot, you repeat for second slot. That means again you make it 0 burette reading, then again pipette out 20 ml, add 10 ml of acidic H2SO4 solution, then start the titration. Here you got the 10 ml. Then in the second case, if you are getting 10.1 ml, then here it is 10 ml, here is 10.1 ml. These two are not concordant reading. Concordant reading means consecutive reading should be same. So for example, here 10.0, here it is 10.1, and again here it is 10.0. So 1 and 3 are same readings. So those readings are not concordant reading because they are not consecutive readings. See, always remember, you are supposed to get the consecutive reading should be same. That means next immediate reading should be same. Then only that is the concordant reading. So for example, here you got 10.5, here you got 10.5. So 10.5 is the concordant reading. Here 10.5 you can write down. So for example, here 10.5, here 10.4, and here 10.5. No, nothing is concordant. Say for example, 10.5, here 10.4, 10.4. Yes, 2 and 3 are concordant. 10.4 is the volume of KMnO4 used. So that is the concordant reading. So after completion of this titration, you go for calculation. See, as per the law of equivalence, N1V1 is equal to N2V2. N1V1 is the ferrous ammonium sulfate solution. N2V2 is the potassium permanganate. We have to calculate the normality of potassium permanganate. So N2 is the question mark. N1, ferrous ammonium sulfate strength was given, N by 100, 0.01. V1, we are pipetting 20 ml of ferrous ammonium sulfate solution into V1 by V2. V2 is the concordant reading, the volume of potassium permanganate consumed. So here we are required to write that V2. Then calculate the normality of potassium permanganate. So this is, okay, with the help of ferrous ammonium sulfate solution, ferrous ammonium sulfate solution strength was given. That means normality was given. So with the help of this, you are calculating the normality of potassium permanganate. This is the first observation table. Now, in the second observation table, yes, here potassium permanganate is acting as an intermediate solution. So with the help of potassium permanganate solution, now we are calculating the strength of ferrous sulfate solution, because see, the ferrous sulfate solution, ferrous ammonium sulfate solution is also a reducing agent. Then ferrous sulfate solution is also a reducing agent. We cannot titrate ferrous ammonium sulfate against ferrous sulfate solution. समझ में आ रहा है ना? Hello?
Yes, sir.
Please be alert. Because as it was started late, so I'm slightly fast. So here what we are doing, with the help of ferrous ammonium sulfate solution, we are determining the normality of potassium permanganate. That intermediate solution, which we calculated the normality by the titration of potassium permanganate against ferrous sulfate solution, ferrous ammonium sulfate solution, that came in a form may be used for the second observation table. That means second observation table titration is titration between potassium permanganate against unknown ferrous sulfate solution. So here again same, pipette out 20 ml of ferrous sulfate solution. Earlier you pipette out ferrous ammonium sulfate, but here we are pipetting the ferrous sulfate solution. Then initial reading 0, final reading. That means pipette out 20 ml, add 10 ml of H2SO4, then start the titration. When the solution turns to dark red, pinkish red color, stop the titration, note down the end point. Then repeat the titration to get the concordant reading. So you please remember that you are supposed to get the concordant reading. Concordant reading means the consecutive reading should be same. Consecutive. Next immediate reading should be same. Okay. Then another mistake is, see, when you are doing the titration, the first one, let us assume that the first one, you don't know at what point the end point will occur. So if that is the case, what happened? Okay, by mistake, that means unknowingly, you may add some more amount of potassium permanganate. Okay, during the titration, okay, 1 or 2 drops, you may add some more extra. Let us assume that in the first case, you got 12.0. Let us assume that. Then second case, if you are titrating, see, the second reading always it should be low from first reading. Why? Because in the second case, you are knowing that, yes, the end point of this titration is 12. So you may be very cautious from 10 reading onwards. That means normally what is our habit? Okay, simply we used to titrate till color change. Okay, sometimes what students used to do, okay, yes, our endpoint is 12. Yes, directly you add it very fastly, okay, up to 10. Then after that, then they may very slowly, they are adding drop by drop. But it is not such type of practice. Titration means, what is the titration? The, addition of drop by drop. Okay, you cannot add at a time. Titration means you are required to add the titrant to titrate drop by drop while stirring or while shaking the conical flask. So somehow you got the 12 and second reading, when it is 11, then 11 onwards you are very cautious. Then, okay, 11.1, 11.2, 11.3, that means the second reading by default, it may be lesser than the first reading. That means if it is more than the first reading, that indicates that first reading is the wrong. These are the general observations. General observations. We can look into the readings. Yes, we can guess. Yes, he did the titration wrong. Okay, at least first titration you may get the some high-end reading, but second and third always it should be low. These are the general observations you keep in your mind. Now, okay, the second titration is potassium permanganate against ferrous sulfate solution. You do the titration. Then second observation table, again N2V2 is equal to N3V3 calculation. This is N2V2 is the potassium permanganate, N3V3 is the ferrous sulfate solution. That ferrous sulfate is the hydrated ferrous sulfate solution. N2V2, normality of potassium permanganate, that is the intermediate. That means with the help of ferrous ammonium sulfate, we calculated the normality. That means this normality, here we calculated the normality, that normality we are using. V2, volume of potassium permanganate, that is nothing but concordant reading. Then N3 is the question mark. We have to calculate the normality of ferrous sulfate solution. V3 is the 20 ml. We are pipetting 20 ml of ferrous sulfate solution into conical flask. Then calculate the normality of ferrous sulfate solution. Then you calculate the strength. How we are calculating the strength? Strength is equals to normality should be multiplied with equivalent weight. Okay? Normality should be multiplied with equivalent weight. So ferrous sulfate, the hydrated ferrous sulfate equivalent weight is 278. See, its molecular weight is 278. Equivalent weight is also 278 because change in the oxidation number is +2 to +3. That means during the titration, what happened? Okay, that we will discuss. Okay, so equivalent is 278 to 278 into normality. That you would be getting the strength of ferrous sulfate solution. So what is our main aim? Our aim is we have to find out the strength of unknown ferrous sulfate solution. Yes, here we are calculating the strength. How we are calculating the strength? First, initially we are calculating the normality of ferrous sulfate solution. Then after that, we are calculating the strength by multiplying with equivalent weight of ferrous sulfate. अरे समझ में आ गया कि नहीं आ गया? Hello?
Yes, sir. Yes, sir.
Yes, sir.
Okay,
Sir.
see here potassium permanganate is imparting the dark purple color. Potassium permanganate imparting the dark purple color. So because of that purple color, no external indicator is required. So potassium permanganate itself, it acts as a self-indicator. In the redox titration, in the permanganometric titration, which indicator we are using? We may ask at the time of IMOS examination. Then you are required to say potassium permanganate is imparting the dark purple color, hence it is acting as a self-indicator in the permanganometric titration. What is the end point? Dark red color. So how it is redox titration? Because oxidation and redox reactions are taking place simultaneously. How it is taking place? Yes, we can go through the chemistry. See, what is the chemistry is involving in this titration? The chemistry is, even though in the ferrous ammonium sulfate solution or otherwise ferrous sulfate solution, in the both cases, iron is existing in the form of ferrous. That means Fe+2. Ferrous ammonium sulfate solution. What is the oxidation number of iron? That is +2. +2 means ferrous. Then similarly, in the ferrous sulfate solution, what is the oxidation number of iron? That is also +2. That is nothing but ferrous. That means in the both cases, iron oxidation number is +2. Okay, that's fine. Now what is happening? Yes, you go through this chemistry. See what happened. Is the ferrous, initially what is happening? Ferrous ammonium sulfate is titrating against potassium permanganate. So in the first titration, what is the chemistry or what type of reaction is going on? Yes, see here, the potassium permanganate will oxidize the ferrous ions into ferric. That means removal of electron is going to take place. See, this potassium permanganate that is removing the electron from ferrous and that is converting into ferric. Then manganate, as it is absorbing the electrons, itself it is getting reduced. That means potassium always, what is the definition of oxidizing agent? Oxidizing agent definition is that is going to oxidize the other substance but itself gets reduced. This type of definition may ask at the Viva's examination. What is the definition of oxidizing agent? Oxidizing agent means that is oxidizing the external substance but itself it gets reduced. So here, in the both cases, either ferrous ammonium sulfate solution or otherwise ferrous sulfate solution, Fe+2 is there. That Fe+2, one electron is removed. So that is going to convert into Fe+3. So this is the oxidation reaction, half of the oxidation reaction. Then second half of the reduction reaction is MnO4 minus. See here, what is the oxidation number of manganese? Yes, here 4 to the 8 minus 1, that is nothing but +7. So here +7 is the oxidation number of manganese. Then the +7 is converting into +2. That means absorption of electrons. So this is the reduction. That means oxidation, half of the oxidation reaction, half of the reducing reactions are taking place simultaneously. Hence it is called as redox titration. Now see here what happened. When potassium permanganate is adding the titrant, that is adding drop by drop to ferrous sulfate solution or ferrous ammonium sulfate solution which is present in the conical flask. See here what is happening. The potassium permanganate is oxidizing the ferrous ions into ferric. Then when all the ferrous ions are converted into ferric, the extra drop of potassium permanganate imparting the pink color to the solution. Hence, the solution turns to pink color. That is the end point. When the solution turns to dark pink color, pinkish red color, then stop the titration, note down the reading. That indicates that all the ferrous ions are get oxidized. No more ferrous ions. So, as we are continuing the titration, when the ferrous ions are converting to ferric, the extra drop of potassium permanganate imparting the dark pinkish red color to the solution. That is the end point. So this is the theory of this is the chemistry of this permanganometric titration. अरे समझ में आ गया कि नहीं आ गया?
So why we add 10 ml of H2SO4?
See, the reaction is continuing in acidic medium. See, the potassium permanganate that is acting as oxidizing agent. So, in acidic medium, it acts indifferently, and basic medium indifferently. See here, what is our object? You go through the object. The strength of ferrous ammonium sulfate solution is N/100. Okay, that's fine. To find out the strength of given unknown ferrous sulfate solution in acidic medium. So, in our object, in our aim, it was clearly mentioned. The reaction is moving in acidic medium. Hence, you conduct the reaction in acidic medium. To maintain the acidic medium, we are adding the 10 ml of H2SO4 solution to the reaction mixture. Yes, clear my point?
Yes, sir.
Yes, any more doubts?
No, sir.
Hello, any doubts?
Sir, do we have to take readings until we get the concordant readings?
Yes. See, say for example, okay, initially, it is a trial and error method. You don't know what is the end point. Blind reading you are conducting. Then with the help of first reading, you would be knowing that how the reaction is moving and at which point you are getting the end point. The first reading, you may treat it as a blind reading or otherwise trial reading. The second reading onwards, you have to be very cautious so that you would be getting the concordant readings.
So, sir, first two readings usually are not concordant readings because
No,
the first
it's not
reading.
like that. Arey beta, see, if any student is doing very carefully, then first reading he got 12 reading. Then second also, if he got 12, yes, first and second may be concordant reading, no doubt. Yes, there may be chances of first and second reading. Immediately first and second also, they may get the concordant reading, no doubt at all. But the condition is, if he is performing the titration very diligently.
Okay, sir.
So, when
yes.
we found the concurrent reading, then we will stop the experiment.
Yes. Let us assume that the first and second readings, if you are getting the concordant reading, then you are not required to repeat for third slot. You stop the titration, so you note down the concordant reading, you go for calculation part.
Okay, sir.
Yes, any more doubt? Yes, please speak out. Don't worry. Don't hesitate to ask any question. Hello?
Sir, one more doubt.
Yeah.
That's in the objective which you just presented. The first line was written, the strength of the solution is N/100. So, sir, but yes, the strength of ferrous ammonium sulfate solution is N/100, but then you showed the formula of strength that it is normality into equivalent weight. So, how can we?
Yes, beta. See here, strength of ferrous ammonium sulfate solution is N/100. That indicates that normality of ferrous ammonium sulfate solution was given. If he is not mentioning N/100, then he is clearly writing that N/100. That means its concentration was given. Yes, what you are saying, that is correct only. Strength should be always calculated, the multiplying the normality with equivalent weight. But here N/100 clearly it was mentioned means its concentration was given. Okay?
Okay, sir. Thank you.
Yes, any more doubt? Yes, any more doubt? Yes, can I close? Hello. Do you have any class next? Can I continue another class? Another
Sir, we have
experiment?
maths class.
Sir, we have workshop, sir.
So we have workshop.
Workshop,
Okay.
sir.
Yes, quick revision. Today's our experiment is permanganometric titration.
Sir, please send this PDF.
Yes. I would be sending the PDF. So permanganometric titration. Today's our experiment is permanganometric titration. Ferrous ammonium sulfate strength was given. Its normality was given. So with the help of ferrous ammonium sulfate solution, we have to calculate the strength of ferrous sulfate solution and potassium permanganate as an intermediate. First titration is ferrous ammonium sulfate against potassium permanganate. There we are calculating the normality of potassium permanganate. Then in the second titration in between potassium permanganate against ferrous sulfate solution. So here, we are calculating the normality of ferrous sulfate solution. Then that normality should be multiplied with equivalent weight of ferrous sulfate solution. Then you would be getting the strength. But here, what is the chemistry? Simple. This is a redox titration. Oxidation, redox reactions are taking place simultaneously. The potassium permanganate is going to oxidize the ferrous ions into ferric. In both cases, in the ferrous ammonium sulfate solution, iron oxidation number is +2, that is the ferrous. Then similarly, in potassium, in ferrous sulfate solution also, iron oxidation number is +2, so that is converted into +3. That means +2, ferrous is converting into ferric. Ferric means Fe+3. So when all the ferrous ions are converted into ferric, the extra drop of potassium permanganate, that is imparting the dark red color or pink color, reddish pink color. Then stop the titration. So this is the chemistry and experiment. Okay?
Yes, sir.
Okay, bye. CR, okay, so I think only one more class is left. Okay, that class we will see. If required, I will continue one more lab in between. Okay?
Yes, sir.
Yes, sir.
Okay. Bye.
Thank you, sir.
Bye.
Thank you, sir.
Thank
Sir,
you,
please send the
Thank you,
PDF of
sir.
polymer also.
Okay. Take it.
Thank you, sir.